Hello, and welcome to the first in a series of lessons about calculus. So first we're going to talk about what calculus is, then the overall plan for this course, and we'll finish up talking about what's up in our next lesson. So first of all, what is calculus? Calculus is the study of three different things. One is the slope of an arbitrary curve, so any curve you could think of. Another is the area under an arbitrary curve, or the area between that curve and the x-axis. And finally, calculus looks at the surprising connection between these two things, or at least the connection which surprised me the first time I learned about it. So the plan for this course. At first, this course is planned to be an atypical approach to high school calculus. If this is popular, I can continue this beyond that. I'm very open to feedback and requests. But as it stands, it's going to be broken into 5 units. The first is prerequisites, or review of things that you should probably have learned before calculus begins. Then we'll look at the slopes and areas of a variety of curves. Some we'll be able to calculate exactly, some we won't. So we'll come up with some decent approximations and find out exactly why we need to use approximations and if there's any way to work around that. Well, the ways to work around them will show up in our third unit, the limits and integrals unit. Then we'll look at deep dives into how the slopes and areas of very specific functions work. So we'll deal with polynomial functions, rational functions, radicals, trigonometric functions, logarithms, and exponential functions. And then finally, we're going to look at some applications of things that are only possible with calculus, things that go beyond slopes and areas, but use a lot of the same tools and toolkits that we've come up with on our own. So up next, we are going to continue our prerequisites unit by looking at the 13 axioms that define the real numbers. Axioms, if you didn't already know, are arbitrary statements that mathematicians assume to be true, but are not required to be true. They just make things more convenient if they are true. And we could completely define the real numbers with 13 of these. So we'll be looking at those in detail in our next lesson. So please join me then.